In this video, I'm going to walk you through the linear project number 1, which is due Friday, March 29th. And I'm going to go in an order that I think is most manageable for me. You can either follow my instructions or do it your own way, but if I were going to do this project, this is the way I would do it. I would first of all go to the easiest lines on the entire project, which are the horizontal and vertical lines. Horizontal lines have a zero slope and are in the format of y equals a number. Vertical lines have an undefined slope and are in the format of x equals a number. So, for example, now line number 15 has an ordered pair with an x value of -20 and a y value of -28, and a second point with an x value of -16 and a y value of -28. So that makes it very easy for me to determine that that's just a y equals, whoops, right here, y equals -28 line. So I'm just going to put that right there in this column that is labeled equation, and we're done with that for right now. I'll come back to that. Same thing on line number 16. You have y equals -28 in the first point and y equals -28 in the second point. So we can take that, copy and paste it. You're going to write that down on your sheet. On line number 25, however, the x values in both ordered pairs are -12. So -12, -12, and -12, -8. Same thing on the next line. Number 26 has two x values that are the same. And so in these cases, we have a vertical line, and then that equation is simply going to be x equals whatever the x value is. So for line number 25, x equals -12. And for line number 26, x equals +12. Okay, so the horizontal and vertical lines starting at line number 15 is where I would start this project. Okay, just x equals or y equals for lines 15 through 32. Now, I will explain to you how to do the domain and range for those. So on the y equals graphs, the horizontal graphs, what we're going to do over here is we're going to give it the restrictions for where to start and stop the lines. And so how we do that is by using curly braces. So let me get this over here in the right place. And we want that line to start and stop at these 2 points right here. And if you remember when we've done some graphing with Desmos, we use the smaller number to the left. And so I'm going to type in over here, I'm going to type in -20 less than or equal to x less than or equal to -16. And then we get the other curly brace and we have our domain restricted to -20 to -16. Okay, let me go over one more of those. On line 16, we want that line, that horizontal line at 28, to start and stop. If we don't give it the start and stop places, then it's just going to be a line that infinitely goes in both directions. So we want it to start and stop at 20 and 16. We can write these constraints two different ways. We could write them as the smaller number on the left. So I would say 16 is less than x is less than +20. Okay. I could also write that as, let me duplicate that. Either one of these is fine. I could put the 20 left side and the 16 on the other side, but then I would go ahead and switch my inequality symbols around. Okay. So when it's an horizontal line, y equals -28, we're going to give it the domain restrictions right here by putting those in braces. Okay, and what we're going to do down here for the x equals a number is we're going to give it the restrictions of the y values. And so in this case on line 25, we want it to start and stop at -12 and -8. But in this case, we are given the equation x equals negative 12. So we are going to make sure that the y values fall between what we noted here, which were negative 12 and negative 8. The smaller one is on the left, and we'll put negative 8 here. Again, you can flip those inequality symbols around. You just need to make sure that the greater than number is on the left side. Okay, for number 26, we want that line to start and stop at negative 12 and negative 8. So actually I can use the same restrictions from that previous line. If you have any questions about the vertical and horizontal lines and then how to restrict those, just make sure you ask first before doing all of them and then risking that you're not doing them correctly. So I think that that would be a really nice way to start this project because they are pretty straightforward. Every single line from 15 down to 32 will either be an x equals a number or y equals a number. And then the constraints are going to be basically the other value that was not used for the line. I'm not sure if that really made sense there, but if I'm going to write y equals negative 28, I'm going to use my x value on the constraints. And if my equation is x equals a number, then I'm going to use my y value or my y numbers as my constraint. My next suggestion for you on the Linear Project 1 is to go through and find all of the slopes for lines 1 through 14. And so I've already typed in a few here. Remember that slope is defined as rise over run, or the change in y over the change in x. And we can go through on a coordinate plane and plot these 2 points and count up and count over to find out what the slope is. But it's a lot easier when the numbers are bigger like this to use a formula. So all I'm going to do is I'm going to take the 2 y values and subtract them and put that over the 2 x values and subtract those and then simplify. So in line number 1, I have 46 minus 8 in the numerator, and then negative 2 minus a negative 4 in the denominator. So 46 minus 8 is 38, and negative 2 take away a negative 4 is negative 2 plus 4, which is 2, and 38 divided by 2 is 19. So I might just go through and type, or in your case, write in that the slope is 19. Okay, let's take a look at line number 3. I took 46 minus 48 in the numerator, which is negative 2, and in the denominator, negative 2 minus a negative 4, which is a positive 2. So I have negative 2 over positive 2, which is a slope of negative 1. Okay. Notice on line number 6, it doesn't matter if I take 54 minus 58 or 58 minus 54, as long as I do the same order with the x values. So in this case, I took 58 minus 54, which is 4, and then 0 minus 1 is negative 1, and 4 divided by negative 1 is negative 4. So the slope for number 6 is negative 4. Coming down to lines 7 through 14, this notation right here says that lines 7 and 8 are parallel. Lines 9 and 10 are parallel. 11 and 12 are parallel. So that's why I joined them together with these little curves here. And there's something important to know about parallel lines. Parallel lines have the same slope. So in lines 7 and 8, you are certainly welcome to calculate the slope individually, but you should get the same exact answer for the slope for these 2 lines, for these 2 lines, and for these 2 lines. I'll show you what I mean there. On line number 7, I set up my equation here, negative 12 minus a negative 28, which would be negative 12 plus 28, which is 16. Okay, so I'm going to put a text box here and type in 16 over. In the denominator, I have negative 12 plus 20, which is a positive 8. And so 16 divided by 8 is equal to 2. So the slope for line 7 is equal to 2. Now remember, I just told you that parallel lines have the same slope, so I should get the same answer of 2 on line number 8, but let's just double check. Negative 16, take away a negative 28 is negative 16 plus 28, which is equal to 12. In the denominator, I have negative 10, take away a negative 16, which is negative 10 plus 16, which is a positive 6, and 12 divided by 6 is in fact equal to 2. Okay, so whatever you get for the slope on number 9, you can write that down for number 10. We're going to do number 11 right now. 4 take away a negative 8 is equal to 4 plus 8, which is 12. Okay, and in the denominator, negative 5 take away a negative 8 is negative 5 plus 8, which is 3. So 12 divided by 3 is 4. The slope is 4 for number 11, which means that the slope is 4 for number 12. So again, my next step in doing this project would be to go through and find the slopes of lines 1 through 14. That's just the way I would do it. And then you are ready to go to the next step. If I were doing this project, the next thing that I would do is focus on the equations that I need to write in point slope form. And point slope form is y minus y sub 1 equals m parentheses x minus x sub 1. And all of the ones that have PS written next to it, those are the ones I want you to write in point slope form. So let's go ahead and do that with the ones that we already have written, or we've already figured out the slope. So for line 6, we figured out that the slope is negative 4. So in point slope form, all we have to do is take y minus one of the y values. I can either use 58 or 54. I'm going to use 58. Y minus 58 equals m, which is slope. We've already figured that out, negative 4. And then parentheses, x minus the x value for that particular point that we use, which is 0. Okay, so there could technically be 2 different answers for these depending on which point you use. Okay, so I'm going to copy and paste that, and we're going to write the other one. I could use this point and say y minus 54 equals negative 4, and then x minus 1. Okay, let's try that with number 8. Number 8, the slope is 2, so we can write in point slope form y minus one of the y values. It doesn't matter which point we use, so I'm going to say y minus a negative 28, which actually turns into y plus 28, equals m, we already calculated the slope to be 2, and then parentheses, x minus the x value. In this case, it's negative 16, so that turns into x plus 16. I won't count it wrong if you write down x minus a negative 16, but just know that that does turn into positive. Okay, you do not need to write both of the equations here. I'm just letting you know right here on line number 8 that you could also write y plus 16 equals 2 parentheses x plus 10 if you used this ordered pair for your point slope. Okay, so there's a couple of different equations that I want you to write in point slope form, and that's what I would do next if I were doing this project. The next thing I'll talk about before ending this segment is the domain or range. Okay, remember that the domain is another word for the x values, and the range is another word for the y values. And you're going to either do the domain or the range, not both. Okay, so I'll do both of them, and then you can decide what you want. Okay, so I'm going to start with line number 6 just so we can finish this one. We want the x values to start and stop at 0 and 1. Okay, I have too many things in the way here, but I want the x values to start and stop at 0 and 1. And so how that's going to look for my domain would be 0 is less than or equal to x is less than or equal to 1. Or I could look at the two y values. I have 58 and I have 54. So I could also choose to write that as 54 less than or equal to y less than or equal to 58. Okay, now notice here I have two different ways to write this. Either one of these would be acceptable. On each one, I have the lower number, the least number on the left, and then the bigger number on the right. And then I have my variable in the middle, and then I have the less than signs. Okay, let's take a look at line number 8. Okay, on line number 8, let's just start with the domains, -16 and -10. Which one of those is the least? Okay, if you said -16, you're correct. So that's where I'm going to start. I'm going to say -16 is less than or equal to x is less than or equal to -10. Or you can look at the y values, -28 and -16. And if you were going to write the range, we would write that as -28 less than or equal to y less than or equal to -16. Again, to reiterate, you can either choose to list the domain, that would be this top one right here, the x values, or the range, here the y values. So for the last part of this video, I'm going to be looking specifically at the problems, at the equations that I want you to write in slope-intercept form. And it takes up a little bit of room, and so if you want to use a separate piece of paper, you can do that. But I've enclosed it all in this blue box here for you to kind of walk you through the steps. Step number 1 is to remember what slope-intercept form is. Y equals mx plus b. In the second step, I have simply traded out the m, the slope, for what we solved for the slope, which was 4, so y equals 4x plus b. And then the next step, I'm just choosing one of the ordered pairs. I chose the ordered pair -5, 4 to substitute in for x and for y. Okay, you could have used -8, -8, and in fact, that might be a better point to use because both the x and the y are the same value, and then you won't get confused about where to plug it in. Either way, you're going to get the same answer. So on this step right here, notice I put in -5 in for x, and then I put 4 in for y. Then I took 5 times -4, which is -20. And then to isolate the variable b right here, okay, to isolate the variable b, I added 20 to both sides. 4 plus 20 is 24, so 24 is b. And the final equation that I'm going to write in slope-intercept form is y equals 4x plus 24. That's where I substitute in the slope that I figured out and then what I solved for b. I realize it's a lot of steps, so I'm going to do one more with you, but I do want you to notice that I did show quite a bit of work, and for these slope-intercept equations that I'm having you do, you might want to use a separate piece of paper. So I'm going to come up here to the top, and we're going to do equation number 1. And I'm going to try to follow the same format that I did on the one I just showed you. So I'm going to start by writing y equals mx plus b. On the second line, I'm just simply going to substitute in what I solved for the slope. In this case, it's 19. So my second line is going to be y equals 19x plus b. The next step is to take either one of these ordered pairs and substitute in the x and the y value. I'm going to use this one this time, -4, 8. 8 is the y value, so I'm going to plug in 8 4y equals 19 is the slope. The x value in this ordered pair is -4. So I'm going to put a -4 there, and then plus b. Okay, just take a second to look at those three steps so far. All I'm doing is plugging in information that I already know. Okay, now I'm going to isolate the variable b right here by getting rid of whatever 19 times 4 is. So 19 times 4 is 76, I believe. Let me just double check. 76, so that's a -76. So I'm going to write down here 8 equals -76 plus b. Okay, and you might want to have a little shortcut here and not show all of these steps, but I'm going to show them for you. I'm going to put plus 76, and when I add 76 to -76, I have isolated the variable b, and then when I take 8 plus 76, I get 84 equals b. Okay, so take a look at that next set of lines showing my work. My final equation that I will write in this box here will be y equals 19x plus 84. Okay, 19x plus 84. As you can see from the bottom of the page, you are going to be spending a couple of days writing the equations and setting the domain and range. And then what you're going to do after that is spend some time typing those into Desmos. When you finish that up, your final thing to do is to send me a screenshot of your Desmos drawing and then hand in this paper. So this last part of the video, I will walk you through typing in a couple of the equations that we've already done. So starting with number 6, line number 6, I'm going to type that in. And the nice thing about Desmos is that it will understand your equation, whether you have written it in slope-intercept or point-slope. So on line 6, we wrote down y minus 58 equals -4 parentheses x minus 0 parentheses. And let's just zoom out here because it does not look like there's a line right now. But if we zoom out, there it is. Okay, and remember that that's going to go in both directions infinitely, so we need to type in those domain or range constraints. You're just going to pick one, and remember how you do that is you use the curly brace, and if you're using your iPad, you can go to ABC, click on the curly brace, and then I'm going to type in 0, and then navigate back to less than or equal to x, less than or equal to 1, and put my end curly brace in there, and now it looks pretty tiny compared to what I had before, so I can, there it is at the very top. Okay, all right, let's try another one. Let's go down to one of the lines we wrote in slope-intercept form, which was line number 11. On line number 11, we have y equals 4x plus 24. So let's come over here. Y equals 4x plus 24. And we have a line on our screen, so that's good. But we need to put in the domain or range. And so we didn't do that in the video, but let's just go ahead and put the range in for the y values. And so I want that line on number 11 to go from -8 to a +4. So how that's going to look on Desmos is curly brace, and we will type in -8 less than or equal to, less than or equal to y, less than or equal to 4. Okay, I don't believe you need the end curly brace, but let's just go ahead and put it in there, and we'll minimize the keyboard, and it looks like there's that line. So notice on line 1 in Desmos, I gave the parameters or the constraints in the domain, and then in line number 2, I use the range. So whether you're using the domain, you're going to type in X or range Y. Remember, I did say that you could flip those around. I could put 4 here, and I could put -8 here, but I'd have to change those to be greater than or equal to, and then greater than or equal to. Still the same line, just a different format of it for the constraints. So let's try one of the vertical or horizontal lines here real quick. So over here on Desmos, we will type in the vertical line x equals -12. That's going to give me a vertical line at -12. And then we're going to give it the constraints, -12 less than or equal to y less than or equal to -8. There is that little vertical line there. So when it's all said and done, you should have a total of 32 lines, and then 33 and 34 are actually ones that we'll go over in class. If you want to feel ambitious and try those on your own, you are more than welcome to do that. But when it's all said and done, this will make a picture that you will send to me via email, and along with that you'll get graded on this worksheet of showing your work. So I hope this video was helpful to get you started and get you on the right path. Of course, you always have your choice of doing things the way you'd like to do them, but I thought it would be nice to have some guidance on how I would approach the project if I were doing it. So if you have any questions, just let me know.